If we were to find intact dinosaur DNA, the possibility of using technology to reproduce a dinosaur would depend on several major scientific and technological challenges. While it's an exciting idea, the process is extremely complex, and there are several critical hurdles to overcome. Let's break it down. Fast das. 1. DNA quality and completeness. Finding intact dinosaur DNA is one of the biggest obstacles. Even if we find well-preserved DNA in a fossil or amber, the DNA would likely be highly degraded after millions of years. Over time, DNA breaks down into fragments due to environmental exposure, making it difficult to reconstruct a full genome. As of now, the oldest viable DNA recovered is from around 1 million years ago, much younger than the 65 million years since dinosaurs went extinct. Thus, the chances of finding complete dinosaur DNA are very slim. 2. Cloning process. Somatic cell nuclear transfer. In cloning animals, one common method is somatic cell nuclear transfer, ESCNT, where the nucleus of a somatic cell, a non-reproductive cell, is inserted into an egg cell that has had its nucleus removed. The egg cell then begins to divide and develop into an organism. If we had intact dinosaur DNA, theoretically, we could use SCNT to clone a dinosaur. But this would require the egg of a closely related species, since dinosaurs are long extinct and no direct egg would be available. Birds are considered to be the closest living relatives of dinosaurs, so we might use a bird egg to insert the dinosaur DNA. However, no bird egg would have the exact same cellular environment needed for a dinosaur embryo to develop successfully. 3. DNA fragmentation and reconstruction. Even if we find fragmented dinosaur DNA, geneticists could try to assemble the pieces into a full genome, but it's not guaranteed that this would work. It would be a massive puzzle, and even with modern sequencing technologies like CRISPR, where we can edit genes, rebuilding an entire genome from fragments remains a monumental task. 4. The need for a surrogate mother. After reconstructing the DNA, we would need to find a surrogate mother to carry the dinosaur embryo. Since dinosaurs are extinct, there are no dinosaurs around to help in the reproduction process. The closest living relatives to dinosaurs are birds, so a bird could potentially serve as a surrogate. However, bird reproductive systems are vastly different from those of dinosaurs, and reproductive compatibility is a huge barrier. 5. Ethical and ecological issues. Even if we could clone a dinosaur, there would be ethical concerns, and welfare of the clone. Cloning a dinosaur would likely raise questions about its well-being. Would the environment be suitable for it? How would it behave in a world that has evolved dramatically since dinosaurs roamed the Earth? 10. Ecological impact. Reintroducing a creature that lived 65 million years ago could have serious effects on modern ecosystems. Dinosaurs lived in a world that was drastically different from today's, so their reintroduction could disrupt ecosystems. Genetic integrity. The cloned dinosaur might not be identical to the original species if we had to fill in genetic gaps using modern DNA or altered genes. 6. The potential of genetic engineering, not cloning. Another possible approach to creating dinosaurs is genetic engineering rather than cloning. For example, scientists could try to modify the genomes of birds, which are the closest living relatives of dinosaurs, to express more dinosaur-like features, such as teeth, longer tails, or more robust skeletal structures. This reverse evolution process wouldn't create a true dinosaur, but could create animals that share some dinosaur-like traits. In fact, researchers have already experimented with this in birds, modifying them to grow dinosaur-like features, such as teeth. Summary. Can we reproduce dinosaurs through technology? Cloning. A dinosaur from DNA is theoretically possible if intact DNA could be found, but numerous technical and ethical challenges make it highly unlikely. Key challenges include DNA degradation after millions of years, the need for a surrogate to carry the embryo, and the lack of complete DNA sequences to ensure the cloned dinosaur would be genetically identical to its ancient ancestor. The alternative might be to genetically engineer a living species, like a bird, to express more dinosaur-like traits. But this wouldn't truly create a real dinosaur. Equus. In short, cloning a real dinosaur remains a huge scientific and ethical challenge. While genetic engineering could bring us closer to creating dinosaur-like animals,